Okay, in this video, we're going to learn how to graph linear equations, and we're going to learn about finding the intercepts. When we say intercepts, we're speaking of x-intercepts and y-intercepts. So the first thing we're going to talk about is the standard form. Standard form equation. What does that equation look like? Your standard form equation is written in the form of ax plus by equals c. All right? And A, B, and C are real numbers. All right? And the only other stipulation is A and B can't both equal 0. One or the other. But that's the standard form equation of a line. So A, B, and C are real numbers. You're going to see the x and or the y in the equation. Your A and your B both cannot equal 0 at the same time. And then we have slope-intercept form. Now, slope-intercept form is going to go back to those literal equations. Because to get your equation in slope-intercept form, we need to solve for y. Now, it's called slope-intercept form because there are two things you can get from that equation. You can get the slope and you can get the y-intercept. So if I have ax plus by equals c, and we can make that 3x plus 4y equals 12. And if I want to get this in slope-intercept form, then the first thing I need to do is solve for y. So I'm going to start by subtracting 3x. That leaves me with 4y equals negative 3x plus 12. You can write that as 12 minus 3x. I prefer the negative 3x plus 12. Then we're going to divide each term by 4. So I have y equals negative 3/4 x plus 3. Now, that equation is now in slope-intercept form. This is my slope-intercept form. Y equals mx plus b. This is the standard form of a slope-intercept form equation. So if I write this equation up under it, y equals negative 3/4 x plus 3. M in this equation represents the slope. Your slope is defined as rise over run. The rise tells us that we're either going to go up or down, depending upon the sign of the slope. And the run says that we're going to go left or right. Right? So we're going to rise up or down, we run left or right. The B here represents the y-intercept. The y-intercept is the point where that graph is going to cross the y-axis. The y-axis is your vertical axis, meaning it's the axis that runs up and down. The ordered pair for your y-intercept can be written 0b. So now we're going to take all of this and we'll go into more details about the slope. And then we're going to use the y-intercept and we're going to practice graphing some different equations. Now, finding intercepts, right? To find the x-intercept, that means I want to know at what point does the graph cross the x-axis. So to find the x-intercept, we're going to substitute 0 in the place of y. All right. So when you're looking for the x-intercept, the y value is going to be 0. All right. So to find the y-intercept, and yep, that's exactly what you're thinking. You're going to substitute 0 in for x. All right, so that means that my x is equal to 0. So once you substitute the 0 in the place of the variable, then we're going to solve to isolate the other variable. So quick example here. All right, if I have 2x minus 4y equals 8. To find the x-intercept, I'm going to put 0 in for y. So 2x minus 4 times 0 equals 8. So that's basically 2x equals 8 because 4 times 0 is 0. So I divide by 2, and my x-intercept is 4. If I write that as an ordered pair, x is 4 and y is 0. Take the same equation, 2x minus 4y equals 8, and we're going to find the y-intercept this time. So 0 goes in the place of x. After we simplify, we're left with negative 4y equals 8. Then I'm dividing by negative 4. And I get y equals negative 2. As an ordered pair, it's 0, negative 2. So that's your intercepts. Now, we're going to use the slope and we're going to use the intercepts to actually graph the lines. So what we have here are the steps to graphing a line. So these are the steps that we're going to use when we go through a couple of examples. And you see here, this is your slope-intercept form equation, y equals mx plus b, and it tells you again that m is the slope and b is your y-intercept. And it says here to graph a line, we're going to graph using the slope-intercept form initially. So here's our first example. It says graph y equals negative 5x plus 4. So the first thing I ask myself, is that equation already in slope-intercept form? The answer is yes. So I'm going to take the y equals negative 5x plus 4, and we're going to break it down. All right, so m is my slope. I know that my slope is negative 5. We need to always make our slope a fraction. So if it doesn't have a denominator, we're just going to put it over 1. Now, because this numerator is negative, then it means to go down 5, and then we're going to go right 1. Okay, remember we're using rise over run. And we can do the opposite. All right, so the opposite would mean that I'm actually going to put the negative with my denominator. And then I would go up 5 and left 1. Okay, and then we got to look at our y-intercept. B is my y-intercept, and it's 4. So as an ordered pair, then it's going to be 0, 4. According to your steps, in order to graph a linear equation, we always start by graphing the y-intercept first. So my y-intercept is 4, 0, 4, says stay in the middle and go up 4. So that's my y-intercept. Now, starting at my y-intercept, I'm going to use my slope to get the other points. So I'm going to start here at negative 4, and I'm going to go up 5 and left 1. Then I'm going to go up 5 again and left 1. Now notice when I did the slope, I started with the bottom one. I started with the up 5 and left 1. So now I'm going to go back to my y-intercept, but I'm going to get points in the other direction this time. So I'm going to start at my y-intercept, and I'm going to go down 5, right 1. Down 5 and right 1. Now, notice it didn't matter if I went to the left or to the right. All of the points still fell in the same line. So now I'm going to connect these points. And this is a line, so that means that it's continuous. And we're going to connect the point, extend it throughout the entire graph, and put our arrows on the end. Okay, the next example. I have 4x minus 8y equals 24. So, first question, is it in slope-intercept form already? Absolutely not. So, we got to work. We got to get this y isolated. So, I start by subtracting 4x from both sides. And I get negative 8y minus 4x equals negative 4x plus 24. Need to slow down here. Then I'm going to divide each term by negative 8. Okay, so I'm going to get y equals, I have a negative 4 divided by negative 8x. Positive 24 divided by negative 8 gives me negative 30. Now, my slope is negative 4 over negative 8. That can be reduced to negative 1 over negative 2. Now, using our knowledge of integers, we know that two negatives make a positive. So my slope here is 1/2, and my y-intercept b is negative 3. So I'm going to write it as an ordered pair, 0, negative 3. So we're going to plot the y-intercept first. So stay in the middle. Because it's negative 3, I go down 3. So that's my y-intercept. My slope here, because my slope is 1/2, then that says to go up 1 and right 2. So we're going to start there. Up 1, right 2, and I put a point. Up 1, right 2 more, put a point. Up 1, right 2. I can continue using this pattern until I run out of space. Okay? Now, what is the opposite of up and right? You got it. Down and left. So we're going to go down 1, left 2. Down 1, left 2. Continue to use this pattern until I run out of space. That's what I want to do. But we need to make sure we're practicing getting at least 2 points on each side of the line, on each side of the y-intercept. We want at least 2 points on each side of the y-intercept. So now we are ready to connect our points. And we have a line. All right, so now I have 3y equals negative 12. Is this in standard form or slope-intercept form? It's in standard form, but because all I have is a y, then I already know that my x was equal to 0 because it's not there. So in the case of equations like these, we just isolate the variables. All right, so I get y equals a negative 4. Y equals negative 4. So if you want to think in terms of a table, I'm going to have x and y. Because this says y equals negative 4, then what I know is every single y value in my table is going to be negative 4. For my x values, I can make them what I want to. So I'm going to do 0, a negative 1, a positive 1, a negative 2. And if we want to add another one, we can put a positive 2. So I'm going to grab 0, negative 4, negative 1, negative 4, 1, negative 4, negative 2, negative 4, and 2, negative 4. So what we have here is a horizontal line. So that's something that you can store in your memory. Whenever it says y equals, then we know it's going to have a horizontal line. And when we say y equals, when it's y equals a number, the line is going to be horizontal. Okay, here we have negative 4x equals negative 24. So, negative 4x equals negative 24. We don't have a y, so I know that my y value is equal to 0. So I'm just going to isolate my x, and I get x equals a positive 6 because two negatives dividing gives us a positive. So we can think back to our little xy chart that we did on the last problem. But here it says x equals 6. So on every single example, my x value is going to be 6. My y values can be whatever we want them to be. So to graph 6, negative 1, it's going to be 6 to the right, down 1. 6, 0, 6 to the right, don't go up any. 6, 1, 6 to the right, up 1. 6, 2, and 6, negative 2. Now, notice all of these points are falling in a vertical line. Connect these points, and that's my graph. A note, when it's x equals a number, then we're going to have a vertical line. All right? So x equals vertical line, y equals horizontal line. All right? So now, make a list of all the questions that you have.